So we're pretty pleased with how things are going, and what we've done now is we've used this machine here to make one of these. So this is our first real battery, if you like. I mean, it walks like a battery, it quacks like a battery, it acts like a battery, it's a battery. And the reason we've done this is so we can do a direct comparison with other cells the same size with our new Wonder Cell. And Steve's going to show you actually how we make one of these, and then I'm going to do the electronics. So over to you, Steve.
Hello there. So a carry on from the hemp batteries that you may have seen Rob doing in previous videos. We've got that to a stage now where we need to take it a bit further and look at verification. So we're hunting around to see who can verify the battery for us. But in the meantime, what we thought we'd do with the aid of our new equipment is to make these little CR2032 cells. So I'm just going to do a quick video of how we go about making these. So we'll take a look at what's going inside the CR2032s. This is our active material on a plate. We've got a separator that goes in between, and we've got a current collector on the other side. You can see where we've been practicing on these. And these are the actual components for the button cell. So we have a top part, a bottom can, and we have a spring to compress all the ingredients together, and some spacers. So what I'll do then, I'll take all these, I'll start cutting them out, and we'll turn it into a button cell. So to get these down into the right sizes to fit in the button cell, we actually tried cutting these out with scissors at one stage, and it took days and days and days, and everyone was different. So what we've got with another piece of vital equipment is the hole punches here. So I'll show you how we use that. We're using 20mm for the separator, so let's do that one first. So that's the cutter, fits nicely in the hole. We've got a range of different size holes here depending on what size cell we're using. We put the separator between the two plates, tighten down, take the cutter, place it in the hole, and the separator is quite a flimsy material really, so you just push it through, and that is the separator disc. Now we come down in size to do the active material plate, which is this one here. You see the active material on that side. We come down to 15mm on this one. So we take the cutter again, place that between the two plates, tighten down, and then with the cutter, sorry, I've got the wrong one there. No, I haven't, I've just got the wrong hole. Again, push through. That's the plate for the active material. Now the current collector is a metal collector, and it takes a bit more of an oomph. So what I'll do, I'll take it over to the vise and I'll show you how we punch that out in that plate. Okay, so over to one of my favourite bits of equipment, the vise. So we've got the current collector trapped between the two plates of the cutter. Just insert the cutter tool in between the vise, squeeze it up, push it through, and there we are. And that saves a lot of bruising of hands. So here are all the components needed to make the cell battery. We've got the negative side cap, top cap. In there it's got a nylon seal. We've got our anode material there. We've got our separator there. We've got our active material covered plate there. We've got a spacer there. We've got a spring, which when we put it all together closes it all up and keeps it nice and firm. And finally we've got the positive plate, which is at the bottom of the can. Now I'll put them all together. So here we have all the components laid out. Now I'll put it all together, and we'll use our new machine to form the battery. So we start with the top end, which is the negative side of the battery, and we add our anode current collector. We then put on our separator. Now we've been soaking some of these separators in our salt electrolyte all night. So that goes on next. And obviously they're a lot larger than the collector plates because we don't want them to touch and short out. Now we've got our current collector with the active material on. So I'll just put a couple of drops of electrolyte on that. Then that goes face down. On top of the separator. Then we have a spacer that goes on top of that. Then a spring that goes on top of the spacer. And then finally we have the positive side of the can, which goes over the whole lot. That's then pushed together until you hear a click, and that seal was then made the seal around the cell. We place that now between the jaws of our machine, with the positive side facing down, the larger part of the can facing down. We lock the pressure, and what we're aiming to do is to reach between 500 and 600 psi. So we just pump the handle, see the jaws closing there. Now it's making contact, I can feel a bit of pressure, so we'll just watch that go up. That's just under 500, one more squeeze, and that's between 500 and 600 psi, so I know that's got enough pressure on it. We unlock the jaws, take our button out, and there it is. Now we can set that up on the bench and test that. What we will be doing is testing it against one of these batteries that we use for our weighing machines or whatever. They're lithium-ion batteries, same size cell, so we'll do a comparison and Rob will show you the results of that.
Okay, so I've been charging and discharging our CR2032 version, which I'm really pleased about because, I mean, it just so much looks like a battery. It kind of feels like we're there now, we're making actual batteries. And I've charged and discharged this in this CR2032 coin holder that I've got here. There it is, it's just a coin holder, makes it so easy to use, so you can just slip the battery in there. And as you can see, we actually getting quite a collection of these things. That makes it easy to clip up and read it on the machine. Now, I can tell you that the amount of active material in here was 0.29 grams. So 0.29 grams of active material held in that device. And as you saw when we made the device, actually most of it is separator and spring clips. So there's quite a lot of empty space in here, really. And you could see what was going on in there and what went in there. Now here's the graphs. Again, and I'm not sure how clear they are, so I'm going to put them as a slide at the end. And we've put them both together. So there's the lithium running there, and there's the hemp running there. So I put them side by side, rather overlaying each other so you can see. And on the lithium one, then we're getting a reading figure of 4.26, I think it was. And the hemp one is 3.77. So you can see that the curves are more or less identical. Now I think that I only put one layer on here, which is why there's so little weight of material. And I probably were going to do another one where I put 2 and 3 layers, so we'll increase the weight of material and see what kind of result we get from that. But they are basically done. Now I've been running these ones for quite a while now, and I suppose I've done about 20 charges and discharges on it, something like that. It takes around about 250 seconds, incidentally, which is 4 minutes or so. I'm not sure, it's 253 seconds actually, to discharge one of these. So quite a few times I can do that. Now this is the one that we're going to send for verification, which is really the real reason we want them in 2032 format. because we can basically hand those over to anybody and they can go in the standard machines and people can verify and test them. And that's clearly the next phase. I mean, what we need to do with this is try a 2-layer and a 3-layer system, because I'm a little disappointed that it's just about lithium. I wanted to beat the pants off lithium in this format, but I also wanted to let you know what's going on. So in this format, with 0.029 grams of active material, it's about the same as lithium. If we can put in 2 and 3 layers, we should be able to double and treble that, but still have the same size of package. Now in the actual lithium, of course, I don't actually know what the weight of active material is in the actual lithium battery, so I can't really tell you how it compares. I can only tell you that once I get this into that form factor, then you've seen it, you know exactly what's in here, then it's more or less the same as lithium. I want to double and treble the amount of active material, see if I can still get into that form factor, and see what we actually get. So I'm expecting to be able to at least treble it, but we'll see on that one, okay? Because all I can tell you is that we've made this one, you've seen how it's made, and it's round about the same as lithium. So our next step is to do 2 and 3 layers and to get that right in this form factor with 2 or 3 layers, and then send it off verification. Now, verification is going to be a matter of me ringing a few labs, going around to see them, having a chat about our needs and their needs, then paying the fee and having it verified. So I'd like to do that as soon as possible. I'm away for 5 days, 6 days from now, because basically I'm going on holiday. I'm tired and I need a break. So I'm going to go on holiday for about 6 days. Then when I get back, I'm going to do the 2 and 3 layers. Then I'm going to give the verification labs, actually I'm probably going to call Warwick, a ring, and then we're going to have it verified. So we're probably, I'm guessing, 4 weeks from verification on this one, something like that. But we've got a long way. And the thing is actually a battery now. So I'm really pleased about that, and I hope you are too. Here's the slide, and thank you very much for watching.